of equilibrium, Lami's theorem, action and reaction, Freebody diagram, elasticity, stress, strain, type of stress, Hooke's law, deformation due to the external force on a body, deformation due to its own self-weight, and principle of superposition, and stress in bar of varying sections. So these much topic. Then in the previous class, okay, in the previous class, we discussed about the how to find out the moment of a force, what is mean by a couple, those things we already learned. And at that time itself, I told you that there exist certain laws of equilibrium. So there exist certain laws of equilibrium. That is the sum of all the forces which is acting on a body will always be zero. The sum of all the forces which is acting on a body is always zero. So that is one. Okay, that is F1 plus F2 plus F3 is equal to zero. Then only we can say that this body is in equilibrium. Suppose a body is there like this. Say F1 is acting in this direction, F2 is acting in this direction. Then the body attains its equilibrium. When it attains equilibrium, F1 plus F2 is equal to zero. Then we can say that this object or this body is in equilibrium. Similarly, the sum of the moments, say M1 plus M2, is also equal to zero. That means F1, say I am going to take a moment from O, that is at here, that is at a distance of X from F1 and Y from F3. Can you say, can you please give me how I can find out the moment with respect to O? Can you say? Once again, I shall give the question. Say this is a body and the force F1 is acting here and F2 is acting here, and I take a point O there, and that is at a distance of X from F1 and Y from F2. I want to find out the moment of this body with respect to O. That is my question. Can you find out? With respect to O, we are going to take up the moment. Okay. And here, this force is acting in this direction. That means it is in clockwise direction. And what about this one? With respect to O, this F2 is acting in this direction. Am I right? That means this is in clockwise and this is in anti-clockwise direction or counterclockwise direction. Isn't it? And hence, I can say that the moment with respect to O due to F1 is F1 into X. Agreed? What happened? I can't get any response from you. Can you hear me? 1 minute. I doesn't have. Yes, yes. Now it is okay. Yes, yes. F1 into X plus F2 into Y. Okay. That's, yes, that is right. F1 into X plus F2 into Y. That is wrong. F1 into X plus F2 into Y. That is also wrong. F1 into X is equal to F2 into Y. Yes, that is right. You got the mistake? That is F1 into X is in clockwise direction. Then minus, why? Because other one is in counterclockwise direction. You have to give a negative sign to denote its direction. That is F2 into Y. Got it? Is equal to 0. That means F1X is equal to F2Y. What about others? Is it clear to all? Okay, okay. Okay, fine. This this is called as, these two things are called as the principle of equilibrium. In states, we can say that if a body, we can say that the a stationary body when subjected to number of forces, that is on that lot of forces are acting, then when that body will be in equilibrium, if the algebraic sum of the forces as well as the moment must be equal to zero, we will represent it like this. That means sigma f equal to zero, sigma m equal to zero. Suppose one more thing also, a force is acting on a body like this, like this, at an angle theta. Okay, a force is acting on a body at an angle theta. Say force F1 is acting on the body at an angle theta. Then here an inclination is there for that force. So you have to resolve that force in horizontal direction as well as in vertical direction also. That is, the resolving the forces in horizontal means, what about this force? Say this is the horizontal force. Am I right? This is the horizontal force and this is the vertical force. Am I right? Say F1x and F1y. What will be the F1x value? That is adjacent side, isn't it? That is adjacent 1 cos theta. It will be F1x. You got it? What will be the other one? F1y will be F1 sine theta. F1 sine theta. This is how we can resolve the forces into, yes, we can resolve the forces into horizontal and vertical forces. If the force is acting at an inclined direction. Clear? Yep. Yep. Okay. Okay. Can you please wait for 2 minutes? I shall change my net connection. 1 minute. It is disturbing. Okay. Can you hear me now? Okay, can you hear me now? Okay. Okay, my internet connection is disturbing me. Now it is fine. So, yeah. What happened, Ranjit? Can you hear me? Okay. Ranjit, what happened? Ranjit. Okay. Yes. Okay, okay, fine. So now we can move through. So where we stop? Yes. That is, I am going to, we know that how to resolve the forces if the force is in inclined direction. So next is you are going to solve. Say two forces are acting on the body like this. Say F1 at an angle theta 1 and F2 at an angle theta 2. Can you please resolve the horizontal forces first? Can you resolve the horizontal forces first? Horizontal forces. Mukundan says that F1 cos theta 1. Is it only the horizontal force? Is that only the horizontal force? That much only is there? Yes. F1 cos angle equals F2 cos angle. Mahendra says like that. Can others agree with Mahendra? Plus F2 cos angle. Let us check. Let us check. See, F1 cos theta 1 will be at an angle here like this, or it is acting the direction like this. And F2 cos theta 2 will be acting like this. F2 cos theta 2. And here it is F1 cos theta 1. Am I right? Both are in opposite direction. So that means F1 cos theta 1 minus F2 cos theta 2 is equal to 0 according to law of equilibrium. This is how you have to resolve the horizontal force. But here it is not over. One more thing is also there. Vertical force is also there. Please resolve it. Please resolve it. Vertical force. F1. Yes. Binu is saying F1 sine angle plus F2 sine angle 2 is equal to 0. Yes. All of you are right. To last one. F1 sine angle minus F2 sine angle is equal to 0. Let us discuss. Say F1 is acting in down direction. Then what about in the case of F2? That also in down direction. Both are acting downwards. Am I right? That means F1 sine theta 1 plus F2 sine theta 2 will be equal to 0. But since these both two forces are acting downwards, the summation is taking place. Okay. Then what is the other thing coming against this one? That is, it is resting on a floor there. Am I right? It is resting on a floor there. That means some opposing force from the floor will also be there. That is reaction force. That is reaction force. Got it what I am saying? This is the action force. This is the action force. And for that, an equal and opposite reaction according to Newton's third law will be there. Okay, so that means F1 sine theta 1 plus F2 sine theta 2 minus R is equal to 0. Got it? Okay, is it clear to all? Okay, fine. Next is how we can find out these, suppose two forces are there. I want to find out the resultant of two forces. In the previous class, we already discussed how we can find out the resultant. Then again, somewhat more methods are there to find out the resultant of force. First one is parallelogram law method. Parallelogram law method. That means, suppose the two forces are acting in one in this direction and other in this direction. Say F1, this one is F2. You have to represent this F1 and F2 on two sides of a parallelogram. Okay, I am going to represent it like that. Okay, so here the force is F2 is acting like this one, and F1 is acting like this one. Okay, F1, F2. Then I am going to complete the parallelogram by means of drawing like this. That is, these two lines are parallel, and other one is you can join or you can complete the parallelogram by drawing another line parallel to F1. Then the diagonal of this parallelogram, the diagonal of this parallelogram will give you the resultant force. This is called as the parallelogram law of forces. Clear to all? If you represent the two forces on as two edges of a parallelogram, then the resultant of the two forces will be obtained from the diagonal of the parallelogram. Clear to all? According to parallelogram law of forces, we will get the resultant force from its diagonal. How? You will represent one of the force along through one of the edge of the parallelogram and other one, sorry, Yes, can you hear me? Yes, okay. Net connection is disturbing me. And here, 1 minute. So here, two edges of a parallelogram, I represent the two forces. Then the resultant will be obtained from the diagonal of this parallelogram. Then this is called as parallelogram law of forces. Clear? Next is, we are going to find out the resultant force by means of triangle law. Let us see what is that. Triangle law of forces. That is, two forces, F1, F2 are there. I take F1 on one side of the triangle and F2 along other side of the triangle, sorry, one other edge of the triangle, say F1, F2. Then I have to join these two endpoints to make it a triangle. Am I right? I have to join these two endpoints to make it a triangle. So I am going to join it by means of a line. That will give you the resultant. That will give you the resultant. That means, say, AB represent the force F1 and BC represent the force F2. Okay. Then AC will give you the resultant. And the direction of the forces is in which direction now? Now, F1 is in this direction, F2 is in this direction. That is, I am moving in the anti-clockwise direction. Agreed? Now I am moving in the anti-clockwise direction. Yes. So the resultant force will be opposite to that direction. Why I say like that? Then only it will be in equilibrium. Then only it will be in equilibrium. See, this will be the direction of force of the resultant. Clear? How I can find out the resultant of the forces with the help of the parallelogram and with the help of triangle? Not only by means of triangle, by means of any polygon, we can find out the resultant force. That means if you express the forces by means of an edges of a polygon, the closing line will give you the resultant. Always the closing line will give you the resultant, and the direction will be opposite to the force motion, force direction. So is it clear to all how I can find out the resultant force? Then one more thing is also there, that is called as Lami's theorem. Lami's theorem. 1 minute. Lami's theorem. That is, say, this is a body and lot of forces are acting on that body, say 1, 2, 3. Say 3 forces are acting on a body like this. Name it as F1, F2, and F3. So if 3 forces are acting on a body at a point, then each force will be proportional to angle between other two forces. Each force will be proportional to angle between other two forces. Let me write the angles first. Say this is alpha, this is beta, and this is gamma. So according to Lami's theorem, F1 by sine gamma, that means F1 is this force. The angle, the sign of the angle of other two forces, that is, this is gamma, equals F2 by sine, which one you have to take? Yes, alpha is equal to F3 by sine beta. This is called as Lami's theorem. That is, if three forces are acting on a point are in equilibrium, each force will be proportional to the sign of angle between other two forces. This is called as Lami's theorem. By this way also we can find out the forces F1, F2, F3. Say if I know F1 and F3 means I can easily find out F2 with the help of Lami's theorem. Is it clear to all? Okay, fine. Now, we are now again discussing about the action and reaction that you might have seen here. Let me take a new whiteboard. So that is our next topic. Action and reaction. Say, we know that for every action on a body, there will be an opposite reaction. Say W is acting, then a reaction force will be there. By its own weight, a reaction will be there. So that we all know. So here, we are supposed to draw the free body diagram. Okay, free body diagram. That means you are just representing the forces only. Actually, the body is lying like this. Say this is one body, this is one body, and which is lying on the floor like this. A force F is acting like this at the point A. The free body, how can I draw the free body diagram is, first of all, you have to take that object from that ground and then represent the point A. Then you have to give the force at A, F. Opposite to that force, there will be a reaction like this from here. That is R. We can give some point name to this point, say B. That means reaction force RB. So this type of representation is called as free body diagram. Free body diagram. Clear? Now, once again, I shall take another example that you have to answer. One circular body is there, and the weight of that circular body is W. It is resting on floor like this. Sorry. It is resting on the floor like this. The point of contact on this body is point A. Can you please give me how the free body diagram appear? First of all, I have to draw a circle. I marked this point and this point. This point is A and this point is B. Then what are the various forces at this body from the top here? Which force is acting? The weight W is acting. And from through A, which force is acting? The reaction force is acting like this. Say RA is acting. This type of representation is called as free body diagram. Okay. And that is required to solve certain problems. So up to that, what we learned today, we learned the first of all, we learned the principle of equilibrium. Say sigma F is equal to 0 and sigma M is equal to 0. Am I right? To attain a body in equilibrium, sigma F is equal to 0, sigma M is equal to 0. Then what about in the case of an inclined force? Sigma Fx is equal to 0 and sigma Fy is equal to 0. How can I get the sigma Fx and Fy? Fx will be in terms of a cos and Fy will be in terms of a sine, based on the angle. Okay. Next is what? After that, we discussed about the various, how can I find out the resultant by means of parallelogram law and by means of triangle law. By means of these two laws, I can find out what the resultant. And after that, we discussed about Lami's theorem. What is the Lami's theorem? If three forces are acting on a body, then the force F1 is acting in this direction, and then that will be equal to what? Or that will be proportional to what? 1 by sine of other angle. That means F1 by sine of the angle between other two forces, isn't it? Say F1 by sine alpha. And if here it is beta means F2 by sine beta. And this one is gamma means F3 by sine gamma. Okay. Then after that we discussed the which one? Action and reaction, and we learn how to draw the free body diagram also. And that is, if a body is weighing there on a resting on a floor and a force F is acting there means what how can I draw the free body diagram? First of all, you have to draw the body, and then force F is represented like this and reaction is represented like this. This type of representation is called as the free body diagram. So by using this knowledge, we are going to solve some problems. After that, we can continue. Are you ready? Okay. Please read this one. Three forces F1, F2, F3 are acting on a body as shown in the figure, and the body is in equilibrium. If the magnitude of force is F3 is 400 Newton, find the magnitude of force F1 and F2. Can you answer? Can you give me a hint by means of which principle that we learned today we can proceed? Yes, by means of Lami's theorem. By means of Lami's theorem, we can continue. Here, the angle between these two forces are not given there. Angle between these two forces are not given there. How can I find out? Let us see how I can find out that angles. Say, this is 30 degree and this is 30 degree. Okay. And what about the total angle of this line, like shown like this? A line representation means what will be the total angle? The total angle will be 180 degree. Yes. For a circle, that will be 180 plus 180. That is 360 degree. Okay. So here it is just half of that. That means it is 180 degree. So I know the full angle 180 minus, and I know this side angle and this side angle is known. So 180 minus 30 plus 30. Okay. That is 120. So 120 is the angle formed by this one. Yes, right. Then what about here? This is a line which is parallel to the ground. Hence, this angle will be 90 degree and this angle will be 90 degree. And what about the angle between F3, F1? What about the angle between F3, F1? Say F3, F1 is 90 plus 30. 90 plus 30, that is also 120. And what about here? That is also 120. That means angles are also always for of all these forces are remain same. That means F2 equals F3 equals what? 400 itself. Yes, you are right. So now it is familiar to you the application of Lami's theorem, isn't it? And it is also familiar to you how you can find out the angles also. Okay, that is required when you when you deal with the free body diagram. Yes. Moving to next question. Three parallel forces F1, F2, F3 are acting on a body as shown in the figure. And body is in equilibrium. Okay, body is in equilibrium. It is given there. If forces F1 is equal to 250 Newton, F3 is equal to 1000 Newton. You gave a problem to solve. Last class, you gave a problem to solve. Okay, have you solved it? I asked it in the class, but all of them say that they already solved. Yes. I think you are a little bit late in the class. Yes, okay. Yeah, okay. And the distance between F1 and F2 is 1 meter is given there. Determine the magnitude of force F2 and distance of force F2, distance of F2 from force F3 you have to find out. Read the question once again. Read the question carefully. Three parallel forces F1, F2, F3 are acting on a body as shown in the figure. And the body is in equilibrium. Okay. Equilibrium means what? Sigma F is equal to 0, sigma M is equal to 0. That is our considerations. Then F1 is given, that is a 250. F3 is also given. What are things we have to find out? F2 is the question mark, and then F2, F3. F2, F3 distance. That also we have to find out. So these are the things we have to find out. How can I find out? Any idea? Yes, with the help of the summation of the force is equal to 0 and the summation of the moment is equal to 0. By using that, we can solve or we can find out the solution of F2 and F2, F3. Mukundan is saying that F2 is equal to 1250 Newton. What about others' opinion? Is he right? Bharat also agree with him. Okay, let us check whether which one is right or wrong. Okay, so here F1 is acting and F3 is acting. F1 is equal to 250 equal to 1000 and F2 is acting like this. Okay, and this distance I want to find out, X. Yes, this distance I know, that is 1 meter. So how can I resolve the forces? Say F1 plus F2 plus F3 is equal to 0. That is 250 plus F2 is what? In opposite direction, that is minus F2 plus F3 is what? Down direction itself, that means it is 1000. So F2 equals 1250 Newton in opposite direction. Yes. So that answer is right. Clear? Next is, I want to find out this distance. How can I find out that distance? X is equal to 1 meter is given by Binu. Let us check whether which is right or wrong. I am going to take the moment with respect to A. Say A, B, C are the 3 points. Okay. I am going to take the moment with respect to A. Yes, moment with respect to A. Listen carefully, all of you. Say, taking the moment with respect to A, F1 into how much? 0. Then, what about the next one? F2 into 1 meter plus is then plus then F3 into what? 1 plus X. F3 into 1 plus X. Is this plus? Can I write plus? If I take this as positive means you have to take this as negative. Okay, yeah. Or if you take this one as negative means you have to take this one as positive. Okay, why? because with respect to this point, the F2 is acting in anti-clockwise direction and F3 is acting in clockwise direction. Okay, so we can put the anti-clockwise direction moment as negative. So that means F2 is taken as a negative. And what is the right hand side? What will be the right hand side? F1 into 0 minus F2 into 1 plus F3 into 1 plus X is equal to what? Yes, 0. According to the law of equilibrium, the sigma m is equal to 0. The moment with respect to a point will always be equal to 0. So here I got F2 1, F2 into 1 equals F3 into 1 plus X. Yes, you are right. F2 into 1 equals F3 into 1 plus X. F2 I know 1250 equals F3. What is F3? F3 is 1000. 1000 plus 1000x. 1000x I got. On solving this, you will get the answer 0.25 meter. So that is the right answer. Is it clear to all? Okay, fine. Moving to the next question. Five forces F1, F2, F3, F4, F5 are acting at a point on a body as shown in the figure, and the body is in equilibrium. If F1 is 18 Newton, F2 is 22.5, F3 is 15, F4 is 30. Find the forces F5 in magnitude and in its direction. That means he is the villain. F5 and the angle we have to find out. Angle with respect to the horizontal we have to find out. Can you find out? Read the question. So here, how you are going to solve this problem? By means of which technique we are going to solve this problem? Resolving the forces by means of no, Ranjit. No, it's wrong. We are going to solve the problem by solving it in horizontal and vertical direction. Got it? You have to find out fx, fy, sigma fx is equal to 0, sigma fy is equal to 0. Like that way you can find out. Okay, I shall explain to you. Listen carefully. Say force. This is a point where the forces are acting. Say F1 is acting in this direction, F2 is acting in this direction, and F3 is acting in this direction, and F4 is acting in this direction, and here F5 is acting. I don't know the direction. And here F2 is at an angle 45 degree, 45 degree from here, 45 degree from here, and this one is 90 degree from here, that is purely vertical, and this one is from the horizontal, it is 30 degree, and this angle is unknown, that is theta is unknown. Okay, so this is the question. And here F1 equals 18 Newton and F2 equals 22.5, F3 equals 15 Newton and F4 equals 30 Newton. F5 equals question mark and theta also question mark. So let us going to solve it by means of horizontal and vertical forces. So first of all, I am going to get sigma fx, which is equal to 0. So 0 equals, please help me, F1 plus, I write take the horizontal force. F1 is a horizontal force. F1 plus, yes, F2 cos 45. Is it minus or plus? Plus. Why it is plus? Why it is plus? Because it is acting along with the direction of F1 itself. Hence, it is in positive direction. Okay. Is it necessary to take F3? F3 cos 90. Is it necessary? No. F3 cos 90. Cos 90 is equal to 0. So, no need of taking F3 because it is purely vertical. No horizontal forces are there. Next is, what about the other one? Any other forces remaining? Yes, minus F4 cos theta. Minus F4 cos theta. Why? Because it is in opposite direction. F4 cos 30. Yes. Next is what? Plus or minus. According to the figure, it is minus direction itself. Am I right? It is taking a negative direction. Okay. So, yes, minus F5 cos theta. I don't know what is theta there. And here that is equal to 0. So now I am going to putting the values there. Say 18 plus F2 cos 45 is 22.5 cos 45 minus F4 is what? How much Newton? Say 30 Newton. 30 Newton, that is 30 into cos 30 minus F5 cos theta is equal to 0. I got it like this. Okay. Then I can get a solution based on F, or I got an equation based on F5 cos theta. Am I right? I got a solution, I obtain a thing like this. Say F5 cos theta equals somewhat. You will get how much? All of you have a scientific calculator? Okay, fine. It is required. If it is not, if you don't have a scientific calculator means you please buy it as soon as possible. Yes, okay. 8. Okay. It is 8. According to Mahendra, it is 8. You next is what about next one? Sigma Fy you have to find out. Okay. 7.57, 7.92. These are various answers. Based on the decimal part you take, it will vary. Okay. So next is I am going to solve the sigma Fy also. Sigma Fy equals. Please help me to find out the sigma Fy. Is it necessary to take F1? Is it necessary to take F1? No, because it is purely horizontal force. No need of taking the F1 there. So you have to take the F2, F2, F2 what? F2 sine 45 plus F3, isn't it? F3, both are in same direction. Then what about the remaining? Minus F4 sine 30 minus F5 sine theta. Am I right? From this, I got an equation for F5 sine theta. Please find out. F4 sine 30, not 60. See, this is at an angle 30. So what will be here? Opposite side will be F4 sine 30. Okay. Mukundan says that it is 15.9. All of you got that? Yes. If anybody have any doubt, please ask. These are basics. Yes, clear. Next is F5 sine theta equals 15.9 and F5 cos theta equals 8. I want to find out theta. I want to find out theta first. What shall I do? Think about trigonometry. Any relationship with the sine and the cos? Yes. We can make it one by means of tan, isn't it? Tan theta equals sine by cos, isn't it? So by using that, we can find out the theta F5 sine theta by F5 cos theta. So F5 get cancelled. So sine theta by cos theta, that is equal to tan theta equals what? 15.9 by 7.92. I got it like this. And hence I can find out the theta equals tan inverse 15.9 by 7.92. Genji says that it is 45. Mukundan says that it is 63.5, which is right. Yes. 64. Okay. 64. Okay, fine. No problem. 64 or 63.5 is the right answer, I think so. So theta equals 63.5 degree. I think you round up the decimal places. Isn't it called that? Yes, okay, fine. No problem. So I can find out the theta also. And then how can I find out the F5? Put that in any one of the equations. Say F5 cos theta equals 7.92. Put into that, you will get the F5. F5 equals cos inverse 7.92, isn't it? Sorry, I made a mistake here. F5 cos theta equals what? 7.92. Okay. Then what is F5? 7.92 by cos theta, isn't it? What is answer? 17.7. Yes, you are right. 17.7 Newton. All of you got that answer? Yes, okay, fine. 17.76. Yes, right. Right answer. So, Ranjit, clear? Okay, fine. Moving to next question. 1 minute. Next question that you can do. Lamp weighing 5 Newton is suspended from the ceiling by a chain. It is pulled aside by a horizontal cord until the chain makes an angle 60 degrees with the ceiling. Find the tension in the chain and the cord by applying Lami's theorem. By applying Lami's theorem. So, shall I give you 5 minutes to do that? Or you want any help? Okay, I shall give you 5 minutes. Don't expose your answers. Please try to do by yourself and please wait. So the concept is, according to the question, the concept is like this. I shall draw the figure. From the ceiling, it is making an angle 60 degrees. And the lamp is holding like this. And the tension is given here. Another tension is for this string in this direction. It is stretching to that direction. Okay. So T2. You have to solve this problem by means of Lami's theorem. I know the weight of this one, that is 5 Newton. Force of this one is 1. Only this angle is known. Shall I proceed? Shall I proceed? What is the weight of the ball? Oh, weight of the ball is 5 Newton. 5 Newton. See this one. Mugundan is saying the T1 as 2.88. Okay. Okay. Can you give me this angle? Can all of you give me this angle? This angle. Okay. Polraj, Denjit, and then Mahendra is saying it is 120. Let us check. Say 60 degrees this one. That means what about this angle? Yes, that is also 60. Why? Because alternate interior angles are same. And what will be the total angle? This will be 180. Okay, hence I got the remaining as 120. That is right. Then what about this one? I know this is 90 degrees. So 60 plus 90, that is 150. What about this one? Since it is drawn horizontally like this, it is becomes 90 degrees. Clear? Remaining things is easy, isn't it? That is 5 by sine 120 equals T1 by sine 150 equals T2 by sine 90. This will be the uh, equation according to Lami's theorem, and what the answer got by Mugundan, given by Mugundan and Bharat, both are right, but one problem is there. What about the units? That is essential. Yes, it is in Newton there. So you have always you have to express the answers by means of its units. Okay. So is it clear? Okay. Yes, T2 is equal to 5.77 Newton. Yes, right. Yes, 2.88 Newton is T1. Right. Okay. Moving to next question. Okay, okay. Yes. One minute. Next question. Draw the free body diagram of a ball of weight W supported by a string AB, resting against a smooth wall at C shown in the figure. Let us see the figure. You are supposed to draw a free body diagram. So all of you please try to draw the free body diagram on a piece of paper. Free body diagram we know, that is the walls or the floor on which the body is resting, we will remove, and after that we will represent the body by means of various forces acting on it. Okay, I am going to give the solution. You check whether your answer is right or wrong. So first of all, body is there, and then the weight of that body is acting downwards. That is one weight, one of the force, W. And then it is held to the wall by means of a string that at point A, say this is point B, so that string is also going to drop. And since it is tied over the ceiling, the force will be in this direction. Okay, force will be in this direction. So that will be another force. See me. Yes, okay. Can you hear? Yes, okay, fine. So here, if the point is taken as C means the force will be, or reaction force will be RC inward like this. Okay. So this is the free body diagram. Is it right for all? Yes, okay. Now it is okay to you. In all years, surely the free body questions are asking. It is asked to about 5 to 7 marks. So you can expect this type of questions. Okay, I have come with a lot of questions from free body. Don't worry. Next is what is here. A circular roller of weight 100 Newton and radius 10 centimeter hang from a tie rod AB equals 20 centimeter. Trusts with a smooth vertical wall at C as shown in the figure. Determine the force F in the tie rod and the reaction RC at a point C. So here you have to draw the free body diagram. This is just as what we drawn now, but somewhat data are given indirectly. Somewhat data are given indirectly. Can you find out the force F in the tie rod and also the reaction? Angle will be 30 degree. Yes. Ranjit is giving me the answer. Angle is equal to 30 degree. Let us see how we can find out the angle. Okay, all of you please listen here. Say, free body diagram is going to draw here right now. This is one thing. And reaction, okay. Reaction force is acting here like this. Okay. And weight is acting like this. Okay. So this is the free body diagram. And this is the body. Okay. And here the tension in the string is acting upwards, named it as FA. And here this is the point B, this is the point A, this is the point C, this force is RC, and W, I know that is equal to how much? 100 Newton. I don't know this theta. How much is the theta is not known. Okay, I want to find out that theta first. For that, I'm going to apply Pythagoras theorem, that is right angle theorem. Okay, so here ABC is a right triangle. Am I right? ABC is a right triangle. AB is the hypotenuse and BC is the opposite side. Agreed? AB is the hypotenuse and BC is the opposite side. Agreed? In this right triangle, AB is the hypotenuse and BC is the opposite side. Then how can I get the theta? By using sine theta, isn't it? Sine theta equals what? Opposite side BC by AB. BC by AB. What is BC there? 10 cm. What is AB there? 20 cm. So what will be the theta? Sine inverse 10 by 20. Sine inverse 10 by 20. That means 0.5. That is sine 0.5 equals 30. So theta I got. Theta is known. Then I want to find out the remaining other forces. Ranjit is giving me 115 and 57. Okay. Let us check what for with the help of others also. So you got the angle theta now. 115 and 57. Okay. Let me check about Bharat and Ranjit also. Sorry, Bharat and Mugundan is over. Mahendra. Bharat, Mahendra, Paul Raj. So how can we solve this one? Resolving it by means of a horizontal and vertical forces. Resolving it by means of a horizontal and vertical forces. Okay, like that way we are going to solve this one. What will be this angle? That will be also equal to theta itself, isn't it? Yes, Mugundan also giving me 115 and 86. So that is a different answer. So we can solve. So here, first of all, I am going to solve it by means of vertical forces. Sigma Fy equals 0. 0 equals 100. that is W, which is acting downwards, minus. What about FA10? How can I write the FA? Upward force, how can I write? Upward force, how can I write? Shall I write FA sine theta? FA sine theta. Is it okay? FA sine theta means it will comes over here. Am I right? FA sine theta means it will comes over here. Isn't it? Not clear to all. Okay, I shall take a whiteboard. 1 minute. So here FA equals that we have to find out, and then F W is equal to 100 Newton. Those things are given there, and this angle theta is known. Okay, we can go according to the usual procedure itself. Say this angle is also equal to theta. Agreed? Okay, okay. Leave it, Bharat. Leave it. You haven't heard anything. Okay, listen here. This is also theta. Then what about this angle? Yes, 90 minus theta. We can write like 90 minus theta. Okay. Bharat, clear? Now you're writing 60. Simply write 90 minus theta. Okay. Then I am going to find out the vertical force. Then it will be, according to your concept, it will be FA sine 90 minus theta. Sine 90 minus theta will be what? FA cos theta. Am I right? Yes. That's why I write FA cos theta. Instead of going like this, by means of this concept, say, I want this force to be on this line. I want this force to be on this vertical line. That means adjacent side. That means adjacent side. That is FA cos theta. What about here? Here, if you take 90 minus theta means the horizontal force will be FA cos 90 minus theta. That will be what? FA sine theta. Okay, Bharat? Is it clear to all? Yes. Okay, fine. Now everything simple. We can put the values over here. That is, first of all, I am going to find out the horizontal forces. That is RC minus FA sine 30 equals 0. Then next is W minus FA cos 30 equal 0. Then what is the other thing? How can I solve this one? Yes, I can find out by means of the second equation. Say by means of this one, I can easily find out because W is known there. From that, F can be find out. FA equals W divided by cos 30. That is nearly 115.4. Yes, you are right. And next is I want to find out RC also. Simply put the value of FA in this equation. I got the value of RC as 57.73. Yes, you can solve it by means of Lami's theorem also. Yes, what Poldraj said is also right. That means you can draw it over here like this. That means it becomes a Lami's theorem. Say RC will be like this. Okay. Yes. So is it clear to all? Okay, fine. Next is, we are moving to the next one. Draw the Freebody diagram of a ball, weight W, supported by. Yes, good morning, Yogesh. Why you are late today? So please go through the recorded session, okay? It seems to be difficult for you to follow for half an hour. After that, we will go to a new session. So from that time, it will be okay to you. So please go through the recorded session. Draw the free body diagram of the ball of weight W supported by a string AB and resting against a smooth wall at C and also resting against a smooth horizontal floor at D as shown in the figure. Okay. Okay, Yogesh. Okay, fine, no problem. Have you gone to the recorded session, Yogesh? Others, please try to draw that free body diagram on a piece of paper. After 2 minutes, I shall draw so that you can check it. Oh, already drawn. Okay. Yes, Yogesh. It seems to be difficult for you to follow, Yogesh. That is, for about 15 minutes, it will be not fine for you. After that, you can join. So please wait. You please go through a recorded session so that you will get a clear picture. Yes, Bharat also drawn. Okay. So all of you drawn. Let us check which one is the right answer. Polraj and Mugundan. Shall I proceed? Drawing. Okay, fine. Drawn. Okay. Mahendra. Drawing. Okay. Point B is there. Point C is there. Okay. So I am going to draw from B. A force is acting like here. 1 minute. From B, the weight is acting like this. And from this point of contact, another force is acting. That is, I am going to name this point as D. RD is acting like this. And from C, the reaction RC is acting like this. And the string make a tension like this, FA. This is the free body diagram. All of you got this one? Okay, fine. Next is you are going to solve. Okay, fine. Everything clear to all. Going to solve a problem. So can you please do this as homework? I shall send you the solution tomorrow so that we can save time. So 1, 2, 3, 3 questions will be there. Okay. So please do that 3 questions as homework. And I shall send you the solution tomorrow itself. Next is I am moving to the another topic. Let me take a right note. where we get can yes, you can download these questions from the news forum that I told you in the previous class. You can download the notes and you can download the questions. Whatever things which I taught can be downloaded from the news forum. Okay, Mahindra. Suggest any book for our reference. For our reference. Uh, I am referring the Mechanics of Solids by Ramus Theorem, and Ramamrudam book is also there. Mechanics of Solids by Ramamrudam book is also there. These two books are much more fine for reference. Okay. And Ramasamy, Mechanics of Solids by Ramasamy. Okay. So after getting the basics from my class, you can, if the time permits, you can go to some other reference also. Okay, fine. Moving to next topic. That is, we are going to discuss about what is meant by elasticity. That we already discussed in the previous class, I think so. That is elasticity. What is that? Whenever I give a force to a material, it will elongate or it will deform. It will deform. It will change its shape. And whenever I release that force, what will happen? It will regain its original shape. That property is called as elasticity or elastic behavior of that material. Got it? Whenever I give a force to a material, what will happen? It will get deformed. Say, if I give a tensile force, that means the forces which are acting in opposite direction of the body, then what will happen? The body will elongate. Am I right? The body will elongate. That means the body length is going to increase. Okay. That means anyway, the deformation is taking place. And whenever I release this force, what will happen? It will regain its original shape. It will regain its original shape. That is called as elasticity. But this can be attained only if we give that force within the elastic limit. If we give that force within the elastic limit. If you exceed the elastic limit of the material means it will not regain its original shape. That means we call that as plastic deformation. Plastic deformation. Once again, I shall give you. If a body is suffered by means of two forces acting in opposite direction means the body will elongate. And that elongation is called as deformation. And if I drop that force which is below the elastic limit means it will regain its original shape. If I exceed that above the elastic limit means what will happen? It will not regain its original shape. And that deformation is called as plastic deformation. Clear? Okay, fine. Then I told you the thing regarding the tensile force. One more stress or force is also there, that is like this. The forces are opposite to each other. Then what will happen? The bulging up of this material will happen. Am I right? Bulging up of this material will happen. That is called as compressive force. That is called as compressive force. Clear? Okay. So two type of forces are there or stresses are there. One is tensile as well as compressive. In the case of tensile, the both the forces are acting in opposite direction. Then in the case of compressive, they are acting towards the body, towards the center of the body. Okay. Then now we are going to discuss about stress. STRESS. You all know the definition of the stress, that is force by area. But the original concept is like this. Say this is the body. I give a force on that. I give a force on that. So what will happen? The molecules inside the body will resist the force. Am I right? The molecules inside the body will resist the force. Okay. That is a reaction force. That resistance force per unit area when an external force is acting, that resistance force per unit area when an external force is acting is called as what? Stress. Resistance force per unit area is called as stress. Clear? In short, we can write it as F by A. Next is strain. Can we call it as opposite force also? Yes, we can call it as reaction force. Reaction force, resistive force. Otherwise, what will happen? here. Okay. Yes, elastic to plastic point, isn't it? That means, yes, till it gains its original position. Yes, yes, Mahendra is giving me the right answer. That is Hooke's law. But what you said by Mugundan and Ranjit is right. That is limit up to which the elastic behavior is there. That is called as the elastic limit. So if you give a force within the elastic limit, the Hooke generated a principle or you generated a law there. That is stress is proportional to strain. Stress is proportional to strain. That means if I plot a graph based on stress as y-axis and the strain along x-axis, then I can see that the stress is proportional to strain. After a particular point, say E, it is not like that. You can see that for a small change in the stress, a larger strain is there, and finally it get breakdown. This is the stress strain curve. So up to this point, which is called as elastic limit, what is happening there? Stress is proportional to strain. So we are going to denote the stress by means of small letter P and the strain by means of a small letter E. So small letter P is proportional to small letter E. Okay. Then we want a proportional constant is there, constant there. That is stress by strain is equal to E. Okay. Stress by strain is equal to E, where E is the Young's modulus of elasticity. That is a property of a material, property of that material. Okay. Young's modulus of elasticity. Modulus of elasticity. Yes, what Benji right is right. So this is called as Hooke's law. What the within the elastic limit, the stress is proportional to strain. That is called as Hooke's law. Is it clear to all the Hooke's law? Okay, fine. Next is I am going to discuss about a derivation there. That is, I am going to find out deformation of a body, deformation of a body due to force acting on it, due to force acting on it. Deformation of a body due to force acting on it. Let us see. Take a body on which a weight is acting there. So I shall take a body on which the weight is acting. W is acting on that body. Or say, I shall take another one. F is acting on that body. Let me check the notations. 1 minute. Otherwise, it seems difficult for you. If I use another notation, it seems difficult. 1 minute. Let me check the notations. Do you want a break? Do you want break? No. Okay. I type all these things. Yes. See here. You can see here. P is the load or force. L is the length of the body. A is the area of the cross section. And P is the stress. And E is the modulus of elasticity. And E is the strain. And delta L is the deformation of the body. So we are going to find out the delta L there. Okay. We are going to find out the delta L there. Okay. So now I am going to take a whiteboard. P is the load acting on the body, and L is the length of the body, and A is the area of cross section of the body. Then small p is the stress, and E is the modulus of elasticity, and small letter E is the strain, and delta L is the deformation. So those things you know. Next is by using, sorry, we know that what is mean by stress? Small p. Can you help me? P is the load, L is the length, A is the area, small p is the stress, E is the smallest, and E is the strain, and delta L. We know. Yes, P is equal to P by A. That means we know. This is equation number 1. Yes. Okay. Capital P by A. Okay. Capital P by A. Here P is the load there, and small p is the stress there. And next is according to Hooke's law. Okay. According to Hooke's law, what is strain? According to Hooke's law, how can we define the strain? Yes, stress by strain is equal to this much. Okay, that means strain is equal to modulus of elasticity into stress. Agreed? Modulus of elasticity into stress. Then what will be the definition for strain? Bharat, my first question is, what is the definition of strain with respect to Hooke's law? That is, stress by strain is equal to a constant called as E. But now the question is not like that. That is your answer. Your answer now it is right. That is, according to the strain concept, the strain is equal to change in length by original length, delta L by L. Okay. Substitute. This is equation number 2. This is equation number 3. Substitute 3 into, what will you get? All of you please listen. We made a mistake there. P by E is equal to elasticity. Then what is mean by strain there? P equals E into elasticity. That means small letter E equals small letter P divided by E. That means equation 2, what I am written is wrong thing, which is right. E equals small letter P by capital E. This is our second equation. Okay. Now substitute the 3 into delta L by L equals small letter P by E. Agreed? Yes. Okay. I am going to rearrange it once again. Say delta L equals small letter P into L by E. I am going to change the stress by means of equation number 1. Equation number 1 is P is equal to P by A. Okay. So I am going to define by means of P by A, that is PL by AE. This will be the deformation of a body due to an external force. Due to an external force. Let us explain once again. So deformation of a body due to the force acting on it, we have to find out. First of all, we can check about the notations. Say P is the load acting on the body. Say capital P is the load and L is the length of the body and A is the area of cross section of the body, and then P is the stress, small p, E is the Young's modulus of elasticity, and small letter E is the strain, and delta L is the deformation. Okay. Then, according to the stress definition, we know that small p equals capital P by A. This is equation number 1. Then, according to Hooke's law, I am going to define the stress. Sorry, going to define the strain. I know that the stress is proportional to strain. Sorry, I am using another notation. The stress is proportional to strain. Okay. Then stress by equals E into epsilon, where E is Young's modulus. This is Hooke's law. I am going to define the strain there. That is E equals P by E. This is equation number 2. Okay. Next is I am going to express the strain equation. Okay. Strain E equals delta L by L. This is equation number 3. Substituting 3 in 2. What you get? Delta L by L equals P by E. This is equation number 4. Okay. Next is what? Substituting 1 in 4. Delta L by L equals, instead of P, small p, we can write capital P by AE. Rearranging this equation number 5, we will get the equation for finding the deformation, that is PL by AE. Clear to all? Okay. Next. Deformation of a body due to its self-weight, that is other thing. Deformation of a body due to self-weight. For that, I shall consider a body first. Say this is a body, I think there, and this is hanging on a ceiling like this. Okay, so this is my body. This one, and A, B is the body, having a length L. Having a length L. Then I'm going to explain the terms used in this to derive this one. Say L is the length of the body, length of bar. Okay. A is the area of cross section, and E is the modulus of elasticity, and small letter W. Okay, small letter W, that is specific weight. Specific weight. What is mean by specific weight is, specific weight means weight of the material by volume. Weight of the material per volume. Weight of the material per volume is called as the specific weight. Clear? So, to solve this problem, I consider a small section from this bar. I took a small section from this bar, having a width of dx. That is length of dx. Length dx. Okay. At a distance x from B. At a distance x from B. Okay. Now, I am going to solve. I am going to find out the deformation. First of all, can you help me to find out the weight of the bar for a length x, that is, now we only consider that small portion dx. We can leave the remaining portions. I am going to consider only that small portion of that bar, say dx. So now we are going to consider a small portion of that bar, that is dx, at a distance x from the point B. Now I want to find out the weight of the bar for a length of x. For a length of x. How can I find out? I know the specific weight, isn't it? I shall write over there, then it will be much more clear. I want to find out weight of the bar till x, or for a length of x. What much will be the weight? I know the specific weight. I know the specific weight. What is specific weight? Please answer. All of you, please answer. What is specific weight? Weight per unit volume. Am I right? Weight per unit volume is the specific weight. So, if the volume is unity, what is volume? L into B into H, area into height is equal to unity. Then, what will happen? W by unit weight. W, the small letter W is given there. Here, my question is, I want to find out the weight of the bar for a length of x. That means this much length I want to find out. If A is the area of cross section, will the area change? Will the area change? Will the area change? No, area will remain same. Area will remain same. Okay, so area is the same there. Then what about the length? It is not at all the full length. That is A into X. So volume is okay. Volume is ready. Then how can I get the weight? That is to be multiplied with the specific weight. Am I right? Okay. Specific weight into volume will give weight of the bar for a length of x. So that part over. Next is, I want to find out the elongation. I want to find out the elongation, or say deformation. Deformation of bar, say a particular, say for that much part, that means for that dx, how much deformation or how much elongation will be there for that dx part. Okay, I am taking that deformation as delta x. Say delta x is the deformation for that part dx. Okay, how can I find out that deformation? From the previous topic that we learned, we know that deformation can be find out, say delta L can be find out PL by AE. Agreed? Okay. So what is delta L there? Delta L, instead of writing the delta L, we have to write delta X there, isn't it? Delta X equals, what will be the weight acting there? Yes, that you can write the P itself. That is, P is the load on the body. Then, isn't it? The P is the load acting on the body. Okay. That is not written there. Okay, P is acting on the body. Then what is L there? L, can I write the full length? Can I write the full length? No, it is X there. Then what about A? Area remains the same. E also remains the same. So this is the deformation of that much part. Px by AE is the deformation of that much part. Okay. Then what will be the next condition? Say I am going to put the value of load or weight which is acting on the body, load or weight acting on a body for a height of x from b. That means I am going to put the value of p there. How can I put the value of p? What is p here? P here is the self weight. Am I right? The P here is self weight. Okay. So what will be the self weight up to the dx? Yes. What Poltraj can all of you agree with what Poltraj is written there? Yes. Okay. Yes. Wx. W into A into X. Yes. Right. So we can write W into A into X over there. Okay. So I am going to write there. I got it like this. Okay. Omega into 2 by E. Okay. Then what about the next one? One minute. Let me refresh my page. 1 minute, please wait. Can you hear me? Okay. Once again, I am going to repeat. 1 minute. All of you, please listen. Up to this one is okay to you. Up to this one is okay to you. 1 minute. Up to this part, it is clear to you. And then delta x is equal to P into x by AE. We are written like that. What is L there? Length of that material, isn't it? Length of that part. Here, what is delta x? That means the change of that particular section. Change in length of that particular section. So what is the length of that particular section? Please help me to find out that length of that particular section. What is written over there? What is the length of that particular section? Yes, it is dx there, but we mistook here as x there. That is the problem. So here it is dx. I am considering a small elemental distance of dx there. So p dx by a. So here it becomes dx. Okay. So w a x dx by ae. I got it like this. W a x dx by ae. Now everything is okay. So this is, yes, W x dx by E. Why? Because A and A will get cancelled. So delta x, that is the small deformation of that part is obtained. Say delta x is equal to w dx, wx dx by e. Okay. Now I want to find out the deformation of the entire body. Which mathematical principle we can apply? Which mathematical operation we can do? Yes, by means of integrating it from 0 to L, isn't it? By means of integrating it from 0 to L, I can find out. Yes, that is delta L can be find out by means of integrating it from 0 to L, Wx dx by E. Okay, in that, which are the constants? Which are the constants? W and E are the constants there, so I can take it out. W by E, integral x dx, integral from 0 to L. So please give me the integration of x dx. Yes, W by E into x square by 2, 0 to L, 0 to L. So how shall I write that? W by E into L square by 2 minus 0 square by 2. This part is eliminated. Then I got WL square by 2E. So this will be what? This will be the deformation of a body due to its own weight. Clear? We can discuss it once again. That is, first of all, I am considering a body like this, which is fastened to the ceiling like this. W is acting downwards, okay? And I consider a small portion here, say having a length of dx, say having a length of dx, and which is at a distance of this is a, this is the x from B. The total length of this object is L. Okay. Now, first of all, I want to find out the weight of that small section, weight up to that small section at a distance x from B. Please help me to find out. That is the specific weight I know, that is W. The specific weight into volume. What is the area here? A. Into what is volume? Sorry, area into length is the volume. So area into height, that means x. So W into A into x is the weight up to x from B. Next is, I want to find out the deformation due to its weight for that small part. For that small part, I take that elongation as delta x. Delta x equals PL by A is our basic equation. So P into what is L there? Dx. What is A? Area. E is Young's modulus due to elasticity. Next is, what is P? P is the weight up to the point x, that is weight of that point, weight of that small section dx. That is, how can I find out? By using this. That is W A, small letter W A, x dx by A. A and A get cancelled. That is W x dx by E. I want to find out the total deformation. That is from 0 to L. That is, you have to integrate this one. Delta L equals integral 0 to L W by E x dx. W by E is a constant. I can take it outside. W by E into integration of 0 to L x dx is carried out. Then I got W by E into x square by 2 from 0 to L. That means I got the delta L as WL square by 2E. WL square by 2E. Is it clear to all? Okay, fine. Next is principle of superposition. Principle of superposition. That means if, okay, I shall draw one figure. After that I shall explain. This is one body and I make lot of sections there. Say A, B, C, D, which is at a distance of x1, x2, x3. Okay. Then here, when I check here, I can see that a force F is acting here, force F2 is acting here, force F3 is acting here, force F4 is acting here. See, on these sections also, the forces are acting here. Clear? In the previous cases, we consider only the forces which is acting either on its ends, but it is not like that. The forces are acting at B, forces are acting at C, forces are acting at D, etc. Not many forces are there. So in such cases, we have to find out it by means of, that is, in such cases, we have to find out the delta L by means of the previous equation PL by AE. First of all, you please consider the length AB, which is having a distance of x1. So what will be the delta L1? Will be F1, am I right? F1, L1, sorry, x1, Lx1 by, if area remains the same means, you can write the area is A. If the elasticity remains the same means, okay, you can write the elasticity also as E. Got it? What about the delta L2 then? Delta L2 will be what? F2, isn't it? F2, X2, F2 into, is it X2? Is it X2? No, X2 minus X1, isn't it? X2 minus X1 you have to take. X2 minus X1, that is the length of that element divided by A into E. Next, what is delta L3? What is delta L3? Please help me. What will be delta L3? This much length you have to take. How much is that? X3 minus X2, isn't it? X3 minus X2. Okay, that much length is known. So what will be delta L3? Delta L3 will be F3, sorry, F4 into, or F3 into, or F4 into what? X3 minus X2 divided by AE. X3 minus X2 divided by A into E. So like that way, it will goes on. Then what will be the total deformation? Total deformation will be the sum of all these. That is delta L is equal to delta L1 plus delta L2 plus delta L3, so on. That means, in short, delta L for a superimposed object can be found out by means of 1 by AE into P1 L1 plus P2 L2 plus P3 L3 plus etc. Clear? Is it clear to one? Next is, suppose the area is also get deferred. Area is also get deferred. Then what about delta L? 1 by E into P1 L1 by A1 plus P2 L2 by A2 plus P3 L3 by A2 A3 plus etc. What about if I may join the materials of join different materials together? Then elasticity also will get deferred. Then it will be P1 L1 by A1 E1 plus P2 L2 by A2 E2 plus P3 P3 L3 by A3 E3. Like that it will continue. So these are somewhat things which are derived from the external force which is acting on a body. Deformation due to external force which is acting on a body. So is it clear to all? So what we learned today? We learn about elasticity. We learn about the stress, that is resistive force per area. We learn about strain, that is change in length by original length. After that, we learn what is meant by Hooke's law. Stress is proportional to strain. That is, stress is equal to E into strain. E is the Young's modulus of elasticity. After that, we learn what the deformation of a body due to an external force we learn. And from that, I got the equation that delta L is equal to, please help me, delta L is equal to, delta L is equal to, yes, PL by AE, yes, right. Then after that, we discussed about the deformation of a body due to its own self weight. That is obtained as WL square by 2, WL square by 2 into E, WL square by 2E. That is the deformation due to its self weight. After that, we discussed about the principle of superposition. In that, we discussed about the material having the different forces and different length, and then different forces, different length and different area, different material also we discussed. So these are the things we discussed today, and now we can do the problems based on that. So these two questions you will perform it as homework. After that, we are moving to the next question that is coming from today's class topic. So, administration relax. Can you see the 12th, sorry, 11th question? 11th question. 11th question. Okay, please read it. A rod of 100 centimeter long of 2 centimeter into 2 centimeter. All of you ready? All of you ready? Yes, okay. A rod of 100 centimeter long of 2 centimeter by 2 centimeter cross section is subject to a pull of 1,000 kilogram force. If the modulus of elasticity of a material is 2 into 10 raised to 6 kilogram per centimeter square, determine the elongation of the rod. Can you find out without my help? I shall give you 2 minutes. Which equation you are going to put there? Oh, you already find out the answer. Mukundan is giving me yes, PL by AE. Yes, you are right. PL by AE is the right equation. Then what is P there? P is 1000. Then L is 100. A is 2 into 2, that is 4. Then E is 2 into 10 raised to 6. Is it necessary to convert the units? No need, isn't it? Because all are in centimeter, all in kilogram. No need of changing that units. So your final answer will be 0.125 unit. Mugundan says it is 0.125. Ranjit, okay, 0.125 centimeter. Yes, always yes, give the answers by using units. Okay, what about others? Bharat, Mahindra, Voltage is giving me 0.125. I think you make some mistake there. It is 0.0125 cm. 0.0125 cm. Yes, okay, fine. So that part over. Shall we move to the 12th question? Yes, a brass bar having cross-section area of 10 square centimeter, that is 10 centimeter square, is subjected to axial force as shown in the figure. Find the elongation of the bar. Take E is equal to 0.8 into 10 raised to 3